You shouldn't worry about optimization before you need to, but some of the steering behaviors can cause performance issues, especially the way I wrote and have been using them. On my decently fast computer, I can have about 3,000 ships if all they're doing is flying straight before dropping below 60 frames per second. But only about 70 or 80 ships using the flocking behaviors before I drop below 60 frames per second. And it seems pretty reasonable that you might want more ships than that. And fortunately, you can have more, a lot more. With some optimization, we can get well over 10,000 ships that fly straight and around 1,000 ships using the flocking behaviors. A couple quick notes before we start. I'm not an expert on code optimization, and so I'm going to keep this very simple. My goal is not to create the fastest possible flocking system GameMaker can handle, just to point out the main bottlenecks and implement a few relatively easy fixes. I'm also going to be showing a lot of code quickly without explaining it in detail because I want to focus on why the code is slow and how conceptually you would go about fixing that. But all of the source code is available in the link below. As an absolute baseline, I tested how many blank objects I could put in a room. The answer on my computer is around 50,000. And the my computer part is important. A faster computer could handle more and a slower one would handle less. And of course, you would see different results on different platforms such as Android or HTML5. Next, let's set a baseline for a ship that just flies straight. Here's the step event for this ship, and you can see that I get around 3,000 before dropping below 60 frames per second. However, if I switch this over to the flocking ships I used in the last tutorial, I can only get around 70 to 80 before dropping below 60 frames per second. So why is flocking so much more expensive than flying straight? The reason, of course, is that we're simply running more code, but it's worse than you might think. The real bottleneck is this loop. All three flocking behaviors have every ship loop through every other ship. This means that with 10 ships, we are doing 100 loops 3 times. With 100 ships, we are doing 10,000 loops 3 times. And with 1,000 ships, we are doing 1 million loops 3 times every single frame, 60 times a second. That's exponential growth and the big reason for the massive difference between our flocking ships and the ships that fly straight. But before we work on that problem, let's do one easy fix. Just switching to the YYC compiler ups the number of basic ships from around 3,000 to more than 8,000. Flocking also sees a significant increase, going from around 80 to 150. And as we discussed, with 80 ships, we're doing around 20,000 loops, but with 150 ships, we're doing around 70,000 loops. So in both cases, we're seeing a better than 3 times improvement. To use the YYC compiler, all you need to do is switch targets up here, but you also have to set it up, which is the hard part. I had to do it for this video as apparently I'd never hooked it up on this computer before and found it to be moderately challenging, but not that bad. I'll put a link to the resources I used down below. Besides the complexity of setting up the YYC compiler, there are a few other things to note. The YYC compiler is not available to the free tier of GameMaker, but all the paid tiers have access to it. And as with all different export targets, you might find something worked one way using the virtual machine and another way in the YYC. The YYC compiler also doesn't let you use the debug console, which is why I'm drawing information to the screen rather than using the debugger to profile performance with the very handy Performance tab. Having covered the easy part, it's time to move on to some actual optimization. And in general, the simplest way to optimize is to, unsurprisingly, run less code. For example, let's take our ship that flies straight. If we knew that it would only ever need to fly straight, we could drop all of this code. And we would jump from around 9,000 ships to more than 17,000 ships before dropping below 60 frames per second. And of course, if you really just need a ship to fly straight, you don't need any of this code. You can just write this and get around 30,000 ships. But if we look at our basic flocker, we appear to be using all of this code. However, as I mentioned before, each of these behaviors loops through all other ships. So one way we could speed this up would be to write a flocking specific behavior that does everything in one loop. This won't get you much of a performance boost, but for me, it goes from around 150 ships to 180. But there's another way we could run less code, and that is with prioritized dithering. I didn't make up the name, this is an idea from Craig Reynolds' original paper. Instead of running every steering behavior every step, he suggests picking a random number and deciding what steering behavior to run based upon that result, weighting those numbers if you desire. So I have implemented a very, very basic system here. I'm using GameMaker's choose function to choose a number equally weighted and then running just one of the steering behaviors based upon the result. This lets us get around 250 ships. And remember that because the amount of code we're running grows exponentially with every ship we add, an increase of 100 ships is actually pretty good. But we can take this idea one step farther. We don't need to run a steering behavior every step. We could run it instead only every other step. There are more elegant ways to do this, but working within the system, I can just add some zeros and change this to an if else. So if 0 is chosen, nothing will happen. I can also wrap this portion in an if statement since it only needs to run if we update our steering force. Now we can get around 350 ships. One thing to point out here is that we are degrading the accuracy of our steering forces. We can counter this a bit by upping the max force variable, but to some extent this is unavoidable. There's a limit to how much code we can run, so if we want more ships we have to limit the amount of code. But there is a better way to limit how much code we're running, and that is to limit how often we do the loop. Right now, whenever we run a steering behavior, we're still looping through all other ships. Instead of doing this, we could have every ship loop through all other ships only once a second and collect the ships that are relevant, and then only loop through the relevant ships, that collection, when we run through the steering behavior. If we do this, we can get almost 250 ships even running every steering behavior every step. And if we combine the idea of caching our ship list with the idea of prioritized dithering, we can now get above 500 ships in this tiny room. And the room size actually makes a difference because in such a small room, even though we're caching a group of ships, that's still a lot of ships to loop through. This ship, for example, is probably close to around 50 or so other ships. So it's got to loop through all 500 once a second, and then every steering behavior still loop through another 50 or more. And of course, that's true for every ship in the room. If I run this exact same thing in a much larger room, we can now get over 1,000 ships before dropping below 60 frames per second, at least as long as they are evenly distributed. There's good news here. When GameMaker first introduced structs over a year ago, they weren't very performant. In fact, when I first switched my steering behaviors over to structs back then, I saw a significant decrease in performance. But that doesn't seem to be true anymore. I switched all the vector scripts over to their array form along with a couple steering behaviors and saw essentially no difference. I might be doing it wrong, so of course the source code is down below if anyone wants to test it out, and arrays themselves may still be faster than structs in terms of pure access speed, but at least when used in steering behaviors, it doesn't seem to matter, which is great because I think steering behaviors are a lot easier to understand and use as structs and have the added bonus of being very similar to how other languages implement them, which makes it a lot easier to translate steering behaviors written in another language into GML. One thing you might notice here is that I haven't really talked at all about how to write more optimized code, as in how to make individual lines of code faster. And there's a few reasons for that. One reason is that I simply don't know enough to teach it well and not say incorrect things. But the other and honestly biggest reason is that for this code at least, the actual code is pretty fast, or at the very least, it's not the bottleneck. For example, as mentioned, I tried using arrays and didn't see much difference. I tried inlining functions, but with the exception of combining all the steering behaviors into one, again, just didn't see much of an improvement. I'm sure that you could make improvements, and if anyone with more skill wants to take a shot at it, please do and comment below to let me know what you tried. But in testing out a few different things, the main bottleneck is simply the loops. I've been getting a lot of great comments on these videos, and I'm starting to get more and more comments requesting certain types of steering behaviors, which is great, and I'll try to address a few of them in the next video.